Welcome into the first video of topic 2, right? And we're going to cover a couple things today, all dealing in what we're going to call, this is the right marker, two-dimensional space. All right, well, as far as two-dimensional space, think of like a piece of paper, or probably your standard XY graph that you're used to, right? So let's draw a standard Y and X axis, right? And I'll move out of the way because I know I'm right behind this graph. So we're in two-dimensional space, our normal XY graph. And the question we want to start addressing is, one, well, how do we graph points, right? And how do we find the distance between, let's say, 2 points? So let's take 2 points. I'm going to write them over here. So we'll call H, and let's say H is going to be -3, +5. Right, so first coordinate having to do with the X value. So we'll go over -3, 1, 2, 3. And I know on your homework it's given to you. Right, you don't have to graph or draw the lines yourself. And +5, right? So 1, 2, 3, 4, 5. So we have a dot right over here, and we're going to call this H. And let's make up another one. We'll call it Q. And let's say this is going to be +2, -3. So again, we'll go +1, 2, -3. We'll put another dot, and I'm going to label this Q. And I'm going to do my best attempt at drawing a straight line. Let's see, I have to like turn my head sideways. Pretend that's close enough. That's not bad. We've seen worse. Right, so we have HQ. All right, we've graphed both the points. We've drawn this straight line. And now the question of interest to us is, what is the distance? What is distance? And it will denote it, right? This line segment, it's going to denote it as H, this is a better color, Q. And it'll put like a line overhead. All right, so we want to know the distance between H and Q. Right, now, there is a nice equation that goes with this, but I kind of want to break this down because this is all coming from finding, right, the sides of a triangle. So, let's go ahead, right, if I'm over here at 2, right, +2 is my X value, and over here my X value is -3. So we're just going to draw a line moving across, right, we'll dot it to here, right? So we're going to just make this triangle, and we'll go up to our actual point. Okay. And what we want to know is, well, what's the distance, right? What's the length of this part of the triangle? Well, we know this X value is -3, right? And we know this one is 2, right? So we're going to take our 2 here, and we're going to subtract our -3. Right, so this distance is going to be 5. Right, there's a distance here from -3 to 2 of 5. Now, if you're like, well, what if we went the other way? Right, that's fine. It would still be a -5, but right, we're really measuring distance here on this in positive values, but that's fine. We'll get to the negative sign in a second if that's the way that you decided to do it. In this case, how far away are we vertically, right, going up? Right, vertically for H, we are 5. Vertically for Q, we are -3, right? Or in other words, right, well, what did we start with? Let's start with the same one. So if we started with Q, which was our 2, let's also start with 3. So -3 minus 5, right? So we do get a -8, but again, if we're thinking about distance, right, you don't think about negative distance really, so we're just going to label this as 8. This will make more sense, right? The negative sign won't play a difference once we start to calculate. Okay? Now what we've constructed here is a right triangle, right? So we have a right triangle. Right, so maybe we remember our equation or how we find, right, the hypotenuse of a right triangle. Right, we have that a squared plus b squared is equal to c squared. Right, this is how we find, right, with this hypotenuse being the c squared. Right, so now we really have all of our information that we need. Right, we can go ahead and at least solve for c squared. Right, to actually find the value of c, which is the hypotenuse, we'll need to take the square root. But let's first just solve for c squared. And then I'll give us the nice formula that goes along with this. Right, so we will go ahead. We have a squared, which is 5 squared, plus 8 squared, which is equal to, let's do the math, 25 plus 64, which is equal to 89. Right, well in this case, right, this is c squared. We want the length of c, right, so let's write this out. C squared is equal to 89, which means that c, I'll write it down here, is equal to the ugly square root of 89. All right, so we'll put this as the square root of 89. Ooh, that's a 9. Right, the ugly square root of 89. Right, so we broke this down into a triangle problem. Right, but let's just go ahead and find it or write it in terms of distance. Right, so now we're going to take what we did in the triangle and essentially show that these are the same as just a distance, the distance formula. Right, so distance here between 2 points is going to be equal to the square root. Right, and you're like, well, why are we doing the square root? What did we do down here? We did it down here as well. We had to take the square root. So we're just saying ahead of time that we're going to take the square root. We're going to do x1 minus x2, and we're going to square it. Right, so what is this? Why does this look familiar? Well, what did we do? We took 2, which is an x1, minus, so 2, x1, minus x2, which was a negative 3, and then we ended up squaring it in our triangle, right? So it's exactly the same. I just broke down the steps a little bit differently, right, to show the triangle. And we repeat the same thing for y, right? So then we said, well, we added it, right? A squared plus b squared, right? Y minus, or y1 minus y2 squared. Right? And that's it. This is our distance formula. Right? So in case we're trying to figure out how does this line up, right? All we did here was, if I'm writing my triangle equation, I essentially am saying the same thing as c is equal to the same thing as the square root of a squared plus b squared. Right? Where a squared was equal to x1 minus x2, so I'm just trying to, again, to show how these connect, squared, and b squared is the y's. Right, so let's stare at that for a second. Let's take a break. We'll come back. We'll do one more example with distance, going all the way through using the equation purely, and then we will touch on midpoints. So quick intermission, be right back. Okay, one more example. Maybe we'll do a couple, but we're going to add a twist onto the end by adding midpoint. Right, so again, we're dealing with two-dimensional space. Right, so we have this xy coordinate system. Label this x and this y. And let's go ahead, we'll give ourselves 2 points. We'll call them A and B this time. So we'll say B is going to be, let's do -3, -4. and we'll say b is going to be, or that was a, b is going to be, let's do 2 and positive 7. Yeah. So we'll go ahead and graph both of those. So let's do a first. We have -3, -4. 1, 2, 3. 1, 2, 3, 4. Put a dot. Call it a. You can call your points whatever you want. I'll use a and b. And 2 and 7. All right, so we'll go 1, 2. That's fine. 1, 2, 3, 4, 5, 6, 7 off the graph, all the way up here. We'll call this b. All right, I'm going to show the triangle one more time just in case I confuse people, but I want to make sure we understand the connection between the two. I think that's one of my better straight lines, a and b. All right, so again, what I'm essentially, you don't have to do this. I'm going to give you the formula. Matter of fact, let's just write down the formula here so you have it, but I want to make sure we understand where it's coming from. Right, so let's write x1, and I'll make another point about this here, squared, plus y1 minus y2 squared. All right, so that's the formula, right? If you just want to plug into the formula and go for it, absolutely. But what this is coming from is just by finding the hypotenuse of this triangle, right? This is a hypotenuse here. If we create this triangle, right, this is at -3, this is at 2, right? So this distance here over horizontally to b is a distance of, let's just figure this out, right? And we'll write this out as we go, right? So if we use a, right, we're going to say x1, which is -3, right? This is my x value of a, right? And I'll even write this here. x1 minus x2 is equal to -3 minus 2. And you can write down -5 if you want. I'm just going to write down 5, right? In terms of distance, the negative sign isn't going to affect anything because we're going to end up squaring it anyways, right? So I'm just going to write 5. But what I do want to make sure is that if I decided that x1 is going to be the -3, then I have to make sure also that y1 is the one that goes with x1, right? This is a key thing. We don't want to get these switched, right? So y1 is going to be -4, right? -4 minus 7. All right, so in this case, we have this long distance here. And this is going to be -11. Again, I'm just going to write it as 11. Right, so we have these two values, right? This is -5, and this is -11. For right now, I'll just write them as positives because they're distances, and if I did it the other way, it would be true, but it's fine for now. Right, so again, this is a triangle. We have one side. We've created a 90-degree triangle here, and we want to go find the hypotenuse of this triangle. That's how we end up getting the distance formula, right? Because we know for a 90-degree hypotenuse, right, or a 90-degree triangle here, right angle triangle, we know that a squared plus b squared is equal to c squared, where c is the hypotenuse, right? So again, I'm just going to line everything up so you can see it, right? This is x1 minus x2 squared, right? That's what ends up being a squared, plus y1 minus y2 squared. This is what ends up being b squared, is equal to c squared, which is really your distance squared. And so if we want to solve for just distance and not distance squared, right, we take the square root, right? So it ends up being the same thing that we have here. So now let's go ahead and utilize the equation. Well, we already did part of our work, right? This is going to be equal to the square root x1 minus x2. We did this, right here, -5 squared, plus y1 minus y2 squared, right? -11 squared. So we end up with 25 plus 121, or the ugly, what is that? The square root of 146. And let's think about that. I don't believe that breaks down any nicer. So we're going to leave it like that for right now. Right? This ends up being a 2 times a 73. I believe a 73 to be a prime number. So it's a co-prime number. So nothing to do, and we would just have to leave it as such. Right? So I lied. I said we were going to do a midpoint problem, but we're going to take a break real quick. I'm going to leave this. We're going to find the midpoint of these 2 points. Right? We could probably squeeze it in, but I don't want to do that. So leave this. We will be right back. So last quick couple examples, right? So we talked about distance in 2 dimensions, right? We're now going to talk about, let's write it over here, midpoint, right? So in other words, and I left the graph up over there since we already have these points labeled. In other words, if I give you 2 points, I want you to find the point that's right in between, the middle between A and B, right? So the way that we find the midpoint, I'll just label it M here for midpoint. All we're going to do is we're going to say, well, we're going to take our first x1, and it doesn't matter which one you do in this case. We're going to take x1 plus x2 and divide it by 2. And we're going to do the same thing with y's, right? So midpoint dividing by 2, cutting it in half, right? If that's the way you want to think about it. And we will divide it by 2. Right, so let's put this to the test, make sure it works. Right, so our midpoint here will be equal to, let's just take x1 and x2. So we have -3 plus 2 divided by 2. And we have -4 plus 7 divided by 2. Okay, so what do we end up with? Well, we have -3 plus 2, -1. The ugly fraction, -1/2. And we also have -4 plus +7, so we have the +3/2. Okay, so we end up with some fractions. That's not going to be great for me to graph on my poorly drawn graph, but we'll give it a try. -1/2, somewhere in here. And +3/2. Somewhere in here. So the dot that we're looking for that is in the middle is right about there. That's M. This is supposed to be an arrow. I think I'm making it worse. Okay. Right, so our midpoint between A and B, right, -1/2, +3/2. Maybe, I know we already have a graph here, so I'm not going to try to graph something else, but maybe try on your own. Let's come up with 2 random points. We'll call them C and D. And let's say this is going to be, we'll do 5 and 2. And let's say D is going to be, let's do -4, +5. Right? And we'll find the midpoint. So pause the video. Take a second. Try this example on your own. Did you pause the video? Okay. So, last one. So, x1, right, midpoint, we'll even label it M again. x1 plus x2, we'll go a little bit quicker. So, x1 and x2, 5 plus -4/2. Do I keep picking bad choices here? No, that's fine. Okay, comma, right, 2 plus 5/2. I keep picking nice fractions for us to deal with. So 5 minus 4 divided by 2, this is going to end up being a 1/2. And this is going to end up being a 7/2. Right, and that is going to be it. Right, and you could double check, right? So 1/2 is 4.5 away from 5, and it's also 4.5 away from -4, right? So it's in the middle of the x's. 7/2, which is 3.5, right, is going to be 1.5 away from 2, and it's going to be 1.5 away from 5. So it's in the middle of the y's, middle of the x's, middle of the y's. We're good to go. right? So midpoint, last one to add on there. Other than that, if you have questions, feel free to ask me. Feel free to ask whoever your instructor is, and you are good to go. Awesome, thanks guys. See you in the next one.